In this example, we're going to be working through this particular limit. Before we work it out together, write it down and complete it, please, on your own first, and then resume the video and watch and see how it's done. That way we can be working on any little things that maybe you weren't too sure about, or if you're getting stuck, then you know how far you're able to get. And it does make the learning experience much more effective. All right, when finding this limit, I don't want to just leap into using L'Hopital's rule. Yes, it's what we just learned about, and so yes, it's probably very likely that you're going to need to use it. But we really do need to check the other things first. Otherwise, if we try to use L'Hopital's rule when it's not warranted, we could actually end up with a misleading or incorrect answer. So first thing I'm going to try here is just direct substitution. Let's actually try that and see what that's going to give us. So I'm going to do the natural log of infinity. And then I'm going to be doing infinity minus 1 on the bottom. Now, infinity can sometimes be a weird concept to work with, but basically, if you think about natural log, is the bigger the number you put into it, the bigger number you get out of it. So if I put infinity into it, I'm going to be getting infinity out of it. On the bottom, infinity minus 1, it doesn't matter what you're actually subtracting. Whether it's infinity minus 1 or infinity minus 1,000,000, it equals infinity. And so we end up getting infinity over infinity here, which is an indeterminate form. We do not know what infinity over infinity equals, but we can do some work to figure it out. That's where L'Hopital's rule comes in. Now, before we use L'Hopital's rule, though, we need to check the other possibilities. Is there any factoring that we can do here? Nope. Is there a conjugate that we can multiply by? Not for any helpfulness, no. Remember, I only use that if there's a radical involved, like a square root. And combining fractions? No, there's just the one fraction there. There's nothing to combine with it. So that means that this checks the boxes for using L'Hopital's rule. We have an indeterminate form, and these did not work. So on to using L'Hopital's rule. The first thing we do is we find the derivative of the numerator and the denominator individually. Now, as we do that, remember to write the limit down here, limit as x approaches infinity. One, it's going to help you keep track of your thoughts and help you remember what the x value is that we're actually going and approaching. But it's also actually just the technically proper way to do it. So yes, keep that there. The only time you get rid of the limit here is when you actually plug in what x equals. All right, so now back to actually finding our limit. I'm going to find the limit by finding the derivative of the top and the bottom individually. So the derivative of the top, that's the derivative of natural log of x. The derivative of natural log is 1 over x. And then that is over the derivative of x minus 1, which is just 1. Before I try plugging anything in, as I look at this can simplify, right? Because anything over 1 is just itself. So I'm going to make this look a little bit easier here. So that's going to be limit as x approaches infinity of just 1 over x. Because it doesn't matter what it is over 1, anything over 1 is just itself. All right, now that we simplified it, let's go ahead and take what x is approaching and plug that in for the x to see what that gives us by direct substitution. So that would end up giving us 1 over infinity. Now you'll notice this is not an indeterminate form. That would be infinity over infinity. 1 over infinity we can actually know. If you take 1 and you try to cut it up into an infinite number of parts, you will end up with parts that are each 0 big. And so that is our final answer here, because any number divided by infinity is 0.